doing chapter 14, gases. Part 2. Gases, where did I leave off last time? Did I get into gases at all? No? Did we finish I think we finished the homework, right, on the previous chapter? Yeah. All right, so we're going to talk about gases here. The first thing we're going to talk about is Avogadro. That is, the volume is directly proportional to the number of moles. And so our book gives us an example here of oxygen gas plus 2 hydrogen gas yields 2 waters for H2O gas. Normally when we do this, stoichiometry is a mole ratio. But since volume is directly proportional to the moles, we could do a volume ratio too. That is, here, 1 mole, 2 moles, 2 moles. As long as these are all gases. If this is, H2O is a gas, then no problem. But what if H2O is a liquid? Well, then it's still the same. It's going to be 2 moles here. So the mole ratio is valid regardless if it's a gas or a liquid. However, we can do a volume ratio. So for example here, this could be 1 liter. And if I have 1 liter of O2, I'm going to need twice as much H2, so I'll need 2 liters. And then I'll form 2 liters of liquid water. But 2 liters depends on the conditions. Typically, we could do it this. This volume ratio works just like a mole ratio because it turns out that volume is directly proportional to the number of moles. If I look at 298 Kelvin and 1 atmosphere, then a mole of gas occupies a certain volume. A mole of gas occupies 24.5 liters. And so if I have a 24.5 liter box, then that's going to be filled with an Avogadro's numbers worth of oxygen molecules. I need 2 moles of hydrogen, so I'm going to have twice as many particles here. So I'll have to have twice as big of a box. So this is going to be 49.0 liters here. And so, in other words, if I take a mole of oxygen, that's 24.5 liters, at 298 Kelvin and 1 atmosphere, room temperature and room pressure, and I mix it with 49 liters of hydrogen, so that would be 2 moles of hydrogen. I should form 2 moles of water. 2 moles of water will occupy 49 liters. So this will be 49.0 liters of water. That's water vapor though. If I'm looking at water liquid, liquid water doesn't occupy that much space. 2 moles of liquid water is 36 grams. Water is 18 grams a mole. So this is 36 grams of water. 36 grams of water occupies how much volume? 36 grams of water occupies 36 milliliters. So rather than getting 49 liters, we're only going to get 36 milliliters of liquid water. And that's because gases are mostly empty space. So if I condense all the water molecules here into a liquid, it's going to occupy much less space, just 36 milliliters. And so the mole ratio and the volume ratio are the same. That's because of Avogadro's law, volume and moles directly proportional to each other. And so when I look at a balanced chemical equation like this, I can say this. I could say 1 volume of O2 requires 2 volumes of hydrogen. it's going to form 2 volumes of H2O gas. The only exception is if it is a liquid or a solid. You know, liquids and solids don't obey the volume ratio. Only the gases obey the volume ratio. And so this is 1 liter. Actually, this is going to be a lot less. Sorry. Down here, this is 24.5 liters, 49 liters, 49 liters here, but it would only be 36 milliliters here. This is liquid water, and for solids, it would occupy even less volume because solids are typically more dense than water. So let's take a look. And so that's what we see in this slide here. This slide would be an application of Avogadro's law. So if I start off with 50 milliliters of oxygen, then I know I'm going to need twice as much hydrogen. So if I have 50 milliliters of oxygen, I'm going to need 100 milliliters of hydrogen. It just depends on how many particles there are of gas. And so the number of particles dictates the volume. So for example, 4 particles of gas occupy this volume. 8 particles of gas occupy this volume. Even though a hydrogen molecule is different in size and weight than an oxygen, it just depends on the number of particles here. So we got these particles moving around. 8. Over here, the same thing, 8 particles of gas are going to occupy this bigger volume here. And so 50 milliliters of oxygen, 100 milliliters of hydrogen is going to produce 100 milliliters of H2O gas. Law of combining volumes. I've got